Is the screen visible?
Yeah,
Yeah.
you're good.
Okay.
Yes.
So thank you for inviting me to this event. It's a great privilege. Hopefully, I can follow up on the last talk. Um, so today, the core topic is going to be related to mental health care, but this is generally applicable to healthcare where there is a similar kinds of problem characteristics. So basically, where natural language processing is involved, and then connecting the different aspects of the natural language descriptions to domain knowledge in these domains. Before we get into the main content of the talk, the outline is going to be that uh, in a domain agnostic manner, I'll give a short technical primer on what is neurosymbolic AI, and then also what does AI-driven healthcare looks like across the entire spectrum. And then specifically, I'll touch upon three facets that have served as some kind of bottleneck in a successful implementation of the research that I've conducted. Um, so the short technical primer is as follows. Generally, you have data generated from a ground truth function. So let's say that function is y equal to x squared. And then in symbolic AI days, you had some kind of domain expertise to be able to reconstruct that function. Here, for example, illustrated is the uh, different basis functions that you might use, x squared and x cubed, to reconstruct this function. And a person can then try and tag each data point to whatever they think is the most relevant basis, and then consolidate all that into a symbolic decision making process. Like here, a decision tree is shown. In this type of construction, one apparent problem is the person may make an error because 1 comma 1 applies equally to y equal to x and y equal to x squared. But because this is a manual sifting process, they may have omitted y equal to x squared, resulting in a decision function that is slightly odd looking. Although it's hard to capture such errors because you may not see it manifest in any kind of test scenario. So if you input 4 into this system, you get, or -2 into this system, like I'm shown here, you get the right answer. So this is kind of the picture of symbolic AI. For neural AI, you start with the same data set that is coming from some ground truth function, and you pass it through a neural network with some kind of design choice. And then you get an approximation of your data set. And normally, the theory suggests that that approximation is interpolative in nature. So it definitely will do well on your data set, but generalize poorly too far out of that boundary. And a big problem with the neural network is its black box. You cannot know very easily what is the internal mechanistic process by which the inputs get mapped to outputs. So now neurosymbolic AI is an effort to merge the pros of both symbolic AI and neural AI. And here in the illustration, say you had the same data set and the same kind of domain expertise, the set of basis functions to start with. The human error in omitting mapping of 1 as a data point to y equal to x square would not happen in this case, presumably, because a neural network would identify that this mapping is also plausible for that data point. Now, a symbolic reasoner that you construct on top of this new mapping will probably result in closer to the ground truth function. So this is the only slide on neurosymbolic AI, the technical details. And now from here on out, it'll be just the application. But I'm happy to answer any more questions on this afterwards. Uh, so the space that I work in the spectrum of virtual health assistants, is the case where you have some kind of app through which you record data, text data mostly. And these data are useful to clinicians to derive insights. And those insights can take the form of summary explanations, they can take the form of decision support information. Hopefully, they're contextualized appropriately for a given patient. And then they are also presented in intuitive ways for the human to understand. On the left side of the spectrum, you have purely monitoring style tasks. So if you have a device like a Fitbit on your person, your phone already records a lot of health information about you, for example, if you keep those apps on. And on the right-hand side, you have procedures that are more or less invasive in nature. So neuroimaging, for example, that's the other end of the spectrum. Many times what happens in the part that is highlighted in green is there is abundance of domain knowledge available in the form of questionnaires, knowledge graphs, and so on. And my work focuses on how can you leverage that within a neurosymbolic AI setup to deliver outcomes that are useful to the clinician. So we'll take a look at a case of depression assessment using a purely neural network-based approach. This is specifically done using BERT. This was a couple of years ago. And you can highlight parts of the input text that BERT focuses on using an XAI technique. And the techniques could span different types of underlying mathematical treatments, for example, integrated gradients or other such things. So what we see here is the model is very sure that the label on this text is depression. And also, it provides evidence in the form of highlights in the input text. And contrasting the output that the model produces with the definition of depression, this comes from the NIH official source, we don't see a lot of overlap. So here there's an expert who understands and has studied this definition of depression, getting these inklings of information from the input text. And now there's significant manual effort involved in making a connection. And this kind of outcome is not always the case. Sometimes the highlights may have more apparent connections to the official definition. But the problem we're faced with is the lack of consistency in this procedure. How can we do this in a more principled manner? Here is where the knowledge helps. So if you have a definition of depression and you have some kind of scaffolding structure, so on the bottom left corner of the screen, we see an ontological structure where a subtext could be related to some part of the definition. Subtexts could follow each other. And how can we use this scaffolding structure to make better sense of the input text? Also, you can do entity recognition on the input text and connect it to one particular category of entity, like daily activities. So when you put all that into the mix, the definition of depression connects much better to the input text, and the clinician has less work to do in interpreting the output of the model and can act more appropriately. So in recommendation, following from the previous slide, where the neural network-based processing was used, the recommendation outcomes can be one of the following shown in this bottom right table. So if this depression score as measured through a standard procedure is within those ranges, then the proposed treatment actions are either do nothing, in the sense that just continue to see them, and then take a more structured approach in terms of scheduling follow-ups periodically for the 5 to 9 range. And 10 to 14 is when you have a clinical setting. You need to administer cognitive behavioral therapy or some medication for this person to get better. Going by those decision support tools, this kind of output from the neural network does not help very much with making that type of recommendation. And even if you recalibrate this 0.99 score to that range, 0 to 14, it is in the 14 range. So these models are always confident in what they say, more or less. That has to do with the underlying geometry of the spaces in which they're trained. And so the recalibration does very little for providing meaningful outputs to the expert. Instead, if we use a knowledge-based approach, you get a comprehensive explanation of how the typical questionnaires used in the clinical setting map to the input text. And then how do you optimize these mappings? Because this is a machine learning model. We'll have to design this learning method in such a way that the mapping, if it's right, it translates to decision support down the line in an end-to-end manner. And that can be formulated as a composition of functions that are differentiable. So I've shown a snippet here of how that formulation is done, but I can point to the paper or talk about it later about how precisely that is done. So this kind of output is more useful to the domain expert to actually do some recommendation on, execute some recommendation on. And now finally, this is the uh, part where additional context comes in. So for the same patient, they say a few more things. And now the neural network predicts depression again. And ChatGPT, for example, also predicts several aspects of the text that could pertain to depression and continues with this line of thought. Now, if you include knowledge, then what happens is you realize that this person is now possibly displaying symptoms of pregnancy. And even if their score mapped to something greater than 10, for example, here, maybe medication, which is the score for the range 10 to 14, is not the best choice. And you'll have to change your recommendation a little bit. So that's what I mean by contextualized recommendations here. There could be other things going on that it isn't necessary to place the text in the correct situational context for the expert to act on it optimally. Otherwise, it could have a pretty severe adverse outcomes. The last part is for this patient-centric mental health care assistance. You need an interface for the human to be able to communicate with the AI system cleanly. This is a prototype interface that we're building, and you'll see in a few minutes a full system that we have built. This system has been evaluated by the clinicians that we partner with, and they provided feedback. Based on that, this is the latest version of the UI that they're still not completely satisfied with, but it's the process is still ongoing. So this is the fully built system. It's called Alleviate MH. Alleviate stands for that abbreviation that we see on the screen. And the technology stack that goes into this system is applicable to other domains as well. That's why it could apply to nutrition assistance, for example. So the MH is specifically the mental health case. I will swing back to this demonstration video if we have time afterwards, but it shows the system in action and how it captures the different various examples that I showed in prior slides and more. So, sorry. Okay. But from that demo, I've captured some snapshots to explain what is going on. There's a chatbot view, and then there's a clinician view. Whatever conversation is happening between the chatbot and the patient is presented in the form of a knowledge graph with highlights to the clinician. And a hypothesis is generated based on the highlights so that the clinician can then decide whether or not to act on the hypothesis or leave it alone. Also, part of the clinician view is the specific text that the model is generating. What are the attributes of that text? For example, in this panel we see here, when the bot asks, do you feel nervous? If the person says anything, sometimes what GPT-2, this was implemented first a few years ago, does is ask the follow-up question that, do you feel self-destructive? And the clinician, when we deployed this initially, they told us that you cannot use direct phrasing like that. And so the generative AI model that is generating the text, that needs to be constrained in specific ways to be a little more approachable to the patient. And finally, part of the Alleviate system is, even though the purview of the Alleviate system is mild and mild disorders, relatively speaking, like depression and anxiety, it must be aware of how to assess more severe things like suicide. And that always happens in the background. In case any kind of suicidality is detected, then it also has emergency actions that it can take. This is what I was telling about just a few seconds ago, that the GPT-2 model can generate words like self-destructive, and we have a procedure by which we constrain this speech. Um, and we've written a paper about it. We'll be happy to discuss the details. The long and short of it is that there is a probability distribution that is generating these tokens, one token at a time. And you can recalibrate the probabilities of the tokens based on a Bayesian formulation. So that's how the safety checks are imposed. This is another example of, I showed depression definition, how it is used, and pregnancy definition, how it's used. This is a output from another example that Alleviate has been tested out with, where OCD is also identified, even though, like I said, its primary goal is only to identify depression and anxiety, but it also ends up having awareness of a broader spectrum of mental health disorders because of the knowledge, the generality of the knowledge used in the system. So far I've covered individual-centric issues, but in implementing AI assistance for healthcare, this I would argue is a bigger problem, which is the infrastructure level issues. At least in the state of South Carolina, there are clinicians that have to deal with a lot of red tape, and the procedures for how you deal with certain administrative processes are written extensively across multiple documentation, official documentation, but they're not easily accessible to the clinicians. So what ends up happening is the typical process of service assignment in the state is when you have a patient, or in this case, they try to identify problem behaviors very early in the person's development. So a high school student, in this case, they're trying to figure out, based on some kind of review document about the student's behaviors in class, what should be their service assignment. And the intensive service assignment is when you need all the stuff I've talked about so far, a clinical treatment of the issue. Many times it's okay to just enroll them in more general procedures like management programs. So if they have anger issues, anger management programs, or maybe group counseling efforts. It's not always necessary to bring them into the clinical setting. But right now, because of the infrastructure problems, almost everybody is ending up in the clinical setting, and that's causing a big stress on the healthcare system. So how do you address that problem? So we are in the process, this is not yet implemented, of developing a system to facilitate the conversation between the people that decide what to do with the student. An example conversation you see here, that this person, John, should be part of anger management, but then another person from the administrative body says that that's fine, but because John is 16, they need to also make sure that a professional is present. And finally, the blue person that initially brought up this idea will have to say that the MD is pretty expensive, we don't have budget for that, and then a resolution has to be thought about for that situation. This kind of thing, how can we help the clinicians with, is the current research. We are calling it a co-pilot. The co-pilot will look at all the available knowledge resources that can facilitate the discussion smoothly in coming to an optimal resolution. The AI challenges related to this, that ontologies and knowledge graphs and procedural knowledge have to get involved in, are several, and they're very challenging. Here I'm showing a snapshot of it. For example, the conversation that goes on has to be grounded in ontological elements. Everything in the conversation is not necessary for the machine to process. The procedure by which conflict resolution happens has to be grounded in procedural knowledge, and so on. Also, it's hard for one AI model to handle all of this. It's a very complex piece of machinery. So the strategy going forward is going to be that this gray AI copilot, it divides the task into multiple copilots with their own areas of expertise. So for example, the first copilot has expertise regarding school level issues. The second copilot has expertise regarding district level issues. And the third copilot has um, expertise regarding auxiliary issues like budgets and finances. And how can these work together to deliver the optimal communication experience? The last bottleneck that happens in healthcare assistance is systemic level issues. It's not infrastructure for a particular state, but there's a lot that goes on in healthcare implementation. Privacy issues, how do you manage professional communication between all parties involved? How do you manage ethical considerations? What are the boundaries of innovation that you shouldn't cross? How can you ensure compliance with regular standards that are present today of everything that you build on the software side? This is a gargantuan issue. It's really difficult to deal with when even building a tiny research prototype in this space. And the only solution that I see going forward is to involve all these various disciplines from the very ground up during the development of the system and not do it in a siloed manner, so that later when these issues arise, we don't have to go back to the drawing board and have to make significant changes. Uh, so the majority of the funding for my work is coming from NSF awards, and I've linked that here. And it's connected to a wiki page where the papers that have been published as a result of this work are showcased. Some other links that are maybe useful is my LinkedIn page, which contains different projects that I've engaged in both in industry and academia. My Google Scholar page, my YouTube channel that has a playlist of talks and tutorials that I've given. Many of them go into details of implementation, and other mental health projects that are going on in the AI Institute. Um, so that is it for my presentation. If there is still time, I can play the demo.
Yeah. Thank you again, Kaushik. And in terms of the time, I leave it to Ravi and Ken because they're the overall.
Okay,
How many minutes is your demo?
5 minutes.
Go ahead. I think rather than a question, we would see the demo, right?
Okay.
Okay.
Yeah.
So I'm not sure if you'll hear the audio or if I have to do something specific to share the audio. But let me just play it anyway, and I can narrate what's going on in the
Good.
demo. Yeah. So do you hear the audio?
No,
No.
we don't
Okay.
hear.
So I'll just narrate then. So this is the architecture overview. There are knowledge sources involved. There's a natural language generation pipeline. There's a patient-specific knowledge graph that is maintained at all times. There are safety check criteria that is maintained at all times, stemming from an initial bootstrapping from medical guidelines. The chatbot agent is over here. It operates on the initial set of provider notes from, say, the first meeting with the therapist and the current ongoing conversation record. And so here is an example of a conversation that's going on. I'll show one final snapshot of it. Yeah. So here, when the person is talking about their procedures for handling their depression, they talk about a particular antidepressant, fluoxetine. They also mention that the medication is having some adverse effects on them. And so the knowledge graph helps figure out the necessary information first. For example, is fluoxetine, since it's only available by prescription, the chatbot knows to ask about, do you have enough refills? But then once that kind of information is out the way, you can also check for possible side effects. And you can even check for the side effects being caused by a particular counteraction mechanism with another drug that this person is also taking. And when the knowledge graph is able to discover that information, it can generate a hypothesis, but that the external care provider can then validate. So when that happens, the person goes offline, takes care of the conflict issue, maybe or maybe not helped by the hypothesis that the external care provider can decide, and comes back. So that goes on until the patient's health gets better over time. The last thing that is shown here is how questionnaires are used to assess other auxiliary things that could be going on. Like I mentioned, they may have severe cases of depression, they may have suicidality tendencies, and the bot is constantly listening for this type of occurrence, even though it's not primarily meant to deal with severe cases. So I will send a link to the demo in the chat. You all can have a look at it later then you can also hear the audio, but I'll stop here for now.
Thank you.
Yeah, again, thank you. And we probably run out of time, Ravi. So.
Well, we still want to thank Kaushik for a wonderful approach. It's a very complex approach, not easy to do these mental health studies. I hope there are some models and things that guide people to some standards like we do in the other part of healthcare. Thank you, Ram, for bringing
Yeah,
these
I'm in a meeting.
Yeah.
I'll be up in a minute.
Okay. Terry, you're talking?
Mhm.
I think he has got his mic on by mistake. Okay.
Yes.
Yeah. So anyway, I think we'll bring this to a close, and thank you again, Kaushik, for that wonderful talk. And there's a lot of material there, and I'm sure that people would like to go through your YouTube videos to get into more detail. And because this topic of mental health is an extremely important topic for people all around the globe, so I'm sure that you'll have more. Unfortunately, we are restricted in terms of time here. So again, I would encourage people to go through the websites that he talked about, and the slides will be on the web. This talk is on the web, so whenever you have time, you can go through it again. I know that because there's a lot of material which was presented, so we'll need to go back again and look at some of the things. So the very interesting concepts were presented both by Venkat and Kaushik in terms of how to integrate knowledge networks and neural networks for practical applications. Again, the focus of this session is more on applications because you've seen a lot of foundational aspects of this, how people integrate these things, talked in previous, mentioned in previous talks. So that's why we didn't want to go too. The speakers didn't want to go too much detail in the actual implementations, but rather to provide you a flavor of the applications in pharmaceutical and mental health industries. So with that, I think we'll close the session. And Ravi and Ken, if you can wait for a minute after this, let's discuss the next session.
Ken, any last minute
Yes.
comment?
Thanks, everyone. That was a great panel.
Thank you.
Too bad we couldn't spend more time discussing it. Perhaps we
Yeah.
can do that when we get to the synthesis session.
Yeah.
Next week, we have a risk panel, and we're still putting the risk panel and the following ethics panel together. So I hope everyone can come next week when we're going to have hopefully a very open discussion about risks. Thanks, everyone.
Okay, thank you
And the
again.
session is
Ravi and
now
Ken,
adjourned.
can we wait here for a few more minutes?
Sure.
Yes, I'll just stop the recording.